Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. Today we are going to start with the new chapter, that is the cycloalkanes. Previously already we have covered the different videos related to the fats and oils. Here in this video just we will see basic introduction regarding the cycloalkanes, means what is the meaning of cycloalkanes, then which are the different examples, how the nomenclature of cycloalkanes is carried out. So these are the various points that we are going to discuss in this video. Now I request you, if you are coming first time to this my YouTube channel, then watch my previous videos also related to the pharmaceutical organic chemistry. Also, if you like the content of this my channel, please subscribe to my YouTube channel to get the more videos related to this organic chemistry. So let's begin with our today's session. Now before that, just we will see what are the learning outcomes of this session. After this session, students will be able to define the cycloalkanes, means you should be able to explain what is the meaning of cycloalkanes, then which are the different examples, then also you will be able to give the nomenclature of cycloalkanes. So let's begin with our today's session. Now just let me tell you what is the meaning of cycloalkanes. Now if you see this word, there are two parts we can consider. One is the cyclo, other one is the alkanes. Now alkanes, we are very familiar with this particular word, alkanes. These are nothing but the hydrocarbons, which are nothing but the saturated compounds. Now saturated compounds, those which are only having the single bonds, they are known as the saturated compounds. And alkanes, they are having the general molecular formula CNH twice N plus 2. So these are the normal alkanes. Now what is the difference between the cycloalkane and the alkanes? This is the one thing. When the terminal carbon atoms present between the alkanes, terminal means what? The last carbon atoms which are present at both the ends. If we join the terminal carbon atoms that are present in the alkanes with the help of the single covalent bond, there will be formation of a ring takes place. And as these compounds are like alkanes, which are having some few properties related to the alkanes, and as they are cyclic in nature, they are known as the cycloalkanes. So this is the basic idea about the what is the meaning of cycloalkanes. Numerous critical hydrocarbons. Now hydrocarbons also we are familiar with the hydrocarbons word. Those compounds which only consisting of carbon and hydrogen, they are known as the hydrocarbons. So here these cycloalkanes are also the hydrocarbons. These are known as the cycloalkanes, which contain the rings of carbon that are connected together by the single bond. And in case of alkanes, when the terminal carbon atoms are connected with the single bond, they are known as the cycloalkanes. Now the basic cycloalkanes of equation, that is the CH2 and N. So all the cycloalkanes, they are having the general molecular formula CH2N, make up an especially essential homologous series or the arrangement in which properties change in a considerably more sensational path with expanding the number, that is the number of these groups. Here this N stands for number of these CH2 groups that are present in given cycloalkanes. As we go on increasing this CH2 group, that will leads into the conversion of one cycloalkane into the other cycloalkane. Means along the homologous series we can carry out the increase in the number of CH2, and due to increase in this CH2 groups, that will lead into the changes in the properties of that particular compound. Means every molecule which is differing in the CH2 will have a considerable different property than to those of non-cyclic hydrocarbons. Means non-cyclic, in case of non-cyclic hydrocarbons, if we go on increasing the number of carbon atoms, the properties within that homologous series are not that much changed. But in case of cycloalkanes, this is the another difference. As we go on increasing the number of carbon atoms, that is the CH2, which leads into the considerable change in the properties of that particular compound. Now, the cycloalkanes with little rings means the number of carbon atoms between these rings is ranging from 3 to 6. So, the cycloalkanes with little rings are unique for the displaying a substance properties middle between those of the alkanes and the alkenes. So, as these particular compounds which are having the number of carbon atoms between 3 to 6, and these particular compounds show different physical chemical properties which are lying between the alkanes as well as the alkenes. Now, alkenes are nothing but the unsaturated compounds which are having the double bonds. They are known as the alkenes. Now, carbocyclic or homocyclic compounds which are taking after the aliphatic compounds in their properties are called as the alicyclic compounds or the cycloalkanes. Now, these are also carbocyclic compounds. Carbocyclic compounds means what? These compounds only are having the carbon and hydrogen. Due to the presence of only carbon and hydrogen, as we said that they are only known as the hydrocarbons. But in addition to that, as they show properties related to the aliphatic compounds, though they are having a cyclic ring, they are not aromatic compounds because they does not satisfy the Haeckel rule. That doesn't consisting of any double bonds, and due to which these compounds are also known as the alicyclic compounds. This word is very important. Sometimes questions can be asked that write a note on or the give information related to the alicyclic compounds. In such a case, student doesn't get information that alicyclic compounds are nothing but the cycloalkanes. So you should remember that cycloalkanes are nothing but the alicyclic compounds, which are also known as the aliphatic compounds. Remember, though there is a presence of the ring, these compounds are not aromatic in nature. Cycloalkanes with a double bond are called as cycloalkenes. These are also aliphatic compounds with two folds of the bonds are called as the alkadines. Means if more than one double bond is present in such aliphatic compounds, then they are known as the alkadines. Now we will see how we are going to carry out the nomenclature of these cycloalkanes. As we know that cycloalkanes are the cyclic forms of the alkenes, therefore they are named by using the prefix cyclo to the name of corresponding alkanes. Now we are familiar with the nomenclature of alkanes. Methane, which is a simple alkane which is consisting of only one carbon atom. Then ethane, which consisting of 2 carbon atom. Propane, which is consisting of 3 carbon atom. Now, as we know that when the terminal carbon atoms are joined to each other, which leads into the conversion of our alkane to the cycloalkane. So minimum 3 number of carbon atoms should be there so that terminal carbon atoms will be linked to each other. So propane is the smallest compound which is belonging to this particular series. Means just when we are going to observe the structure of this particular compounds, just we have to add the prefix cyclo, then we have to check the number of carbon atoms and the whatever the number of carbon atoms are present, and accordingly we have to consider the name of the corresponding alkane. Here I have put various examples, like you can see here 3 number of carbon atoms are there, which is known as the trimethylene also, but commonly this is known as the cyclopropane. Here also just what we have done, that cyclo we have used as a prefix and propane is nothing but the compound which is having the 3 number of carbon atoms. That's why this is known as the cyclopropane, which is represented by the normal triangle. Then here you can see, here we have presented tetramethylene, but its common name is again butane. Why butane? Because number of carbon atoms are 4. That's why it is considered as a cyclobutane. After that, a pentamethylene. Pentamethylene, here you can see the structure. Now here commonly it is known as the cyclopentane, where pentane it corresponds to the number of 5 carbon atoms. Similarly, hexamethylene, where 6 carbon atoms are present. That's why it is known as the hexamethylene, and commonly it is known as the cyclohexane. Hexane, it stands for the number of 6 carbon atoms. Then heptamethylene, which is also considered as the cycloheptane. So whatever cycloalkanes are there, in the nomenclature of the cycloalkanes, just we have to write down the cyclo as a prefix, and then plus we have to add the corresponding alkane depending upon the 3-membered ring, 4-membered, 5, and so on. Likewise, this we have to carry out the nomenclature of these particular compounds. These classes of hydrocarbons are carboxylic hydrocarbons, in which carbon atoms are joined by the single covalent bond to form a closed ring of carbon atoms. They are alicyclic in nature and have the general molecular formula CnH twice N. So all cycloalkanes, they are having the general molecular formula CnH twice N. So just we have to subtract 2 hydrogen atoms from our normal alkanes, so that we will get the general molecular formula of the cycloalkanes. Also following are the some homologous members of this particular category. Already we have seen. Now just we have seen, or we have represented the in the form of the different their symbolic representations, like the triangle, then the square, pentagon, likewise. But each that particular compound is having this chain of this particular CH2. As in the introduction also we have discussed that the cycloalkanes are nothing but they are the polymers of this methylene group, that is the CH2 in N. So here also you can see that there is only presence of CH2 as a carbon atom, which leads into the formation of these particular compounds. Now here, as we go on this particular homologous series or homologous members, then it leads into the change in this particular properties. Cyclopropane, cyclobutane, cyclopentane, they will be having considerable change in their particular properties. Also cyclohexane, which looks like a benzene, but actually it does not exist in the form of that particular structure, because due to its aliphatic nature, and it also maintains the tetrahedral geometry of this particular carbon atom. So 109 degree of angle is maintained in the carbon atoms. Lower members of cycloalkanes are usually reported by simple geometrical drawings like triangle, as we have discussed, like for the cyclopropane, then square for cyclobutane, a pentagon for cyclopentane, and hexagon for the cyclohexane. So there is no need to write down the carbon atom, that is the CH2. Just we have to draw a triangle if it is a cyclopropane. There is no need to write down CH2, 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 and then we have to join. Both ways are correct, but generally representation is carried out by using the triangle. The removal of one H atom from cycloalkanes gives rise to the alkyl radicals. Means, like in case of alkanes, if methane is there, and if methane group loses one hydrogen atom, that will lead into the conversion into the methyl group. So similarly, if we remove one of the hydrogen atom of this particular cycloalkanes, that will give rise to the cyclopropyl from propane, cyclobutyl from butane. So this is about the introduction related to the cycloalkanes. Thank you.